Good morning everyone. Today we are going to discuss the topic architecture of 8085 microprocessor. So before going for the architecture, here are some basic features of 8085 microprocessor. 8085 and developed and designed by Intel in 1977 using NMOS technology. 8085 consists of 8-bit data bus, 16-bit address bus, which can address up to 64 kilobyte of the memory. Then there is a 16-bit program counter, 16 stack pointer, 16-bit stack pointer, and 8-bit register, 8-bit general purpose register, which are arranged in pair of 3. Here in this architecture you can see here there are the 6 8-bit register, that is BC, DE and HL register. This register can be used as a 8-bit register separately or a 16-bit register in pair. So the functional unit of 8085 microprocessor consists of accumulator. You can see here accumulator. Accumulator is an 8-bit register used to perform arithmetic logic operation, and it is internally connected to the data bus, internal data bus and ALU. So the next unit is arithmetic and logic unit. You can call it as a brain of a microprocessor. Arithmetic and logic unit is responsible for all the process which are done by the microprocessor. All the arithmetic and the logic operation are performed in this arithmetic and logic unit. The ALU functioning consists of accumulator. You can see here accumulator is connected to the ALU, and the temporary register. The temporary register is the second input of the ALU. Not the temporary register which is present here is not accessible to the user. User cannot access it. That is, the user cannot read the content of temporary register. So if we look at the sequence of operation in ALU, that is, for ALU to perform any operation, the one operand is in the accumulator and the other operand may be in the general purpose register or memory location, which will be transferred to the temporary register. The content of the accumulator and temporary register are considered as the input of ALU, and the specified operation is carried out in the ALU. Okay, you can see here the output of this ALU is connected to the internal database. That means the output of the ALU will be stored again in this accumulator. That is, the result of ALU operation is always transferred in a register, or you can say accumulator, through internal database. And here you can see one more block, that is the flag register. Flag register is used to show the status of the result of ALU. The content of this flag register will be changed depending on the result of the ALU. So arithmetic and logic unit perform some functions like addition, subtraction, logic addition, logic OR, logic XOR, complement, increment, decrement, rotate and clear. So the next block here is the time and control unit. You can see here this is the time and control unit. The time control unit It also controls the data flow between the CPU and the memory and between the CPU and peripheral devices. This unit provides the control signal, status signal, DMA signal, reset. So there are 4 control signals, that is the ready, read bar, write bar, ALE and status signal. There are 3 status signal in 8085, that is S0, S1, IO/M bar. Direct memory access. 8085 can directly access the memory using DMA IC. For that purpose we use 2 pins, that is the hold and hold acknowledgement, and there is a 2 reset pin, reset in and reset out. And here we can see the stack pointer and program counter. These two are the 16-bit register. Program counter is a 16-bit general purpose register. It is used to hold the memory address of the next instruction which is to be executed. And the stack pointer is a 16-bit register which is used to point the memory location called stack. Stack is nothing, just a part in a memory which can be used as a stack. So the stack is a sequence of memory location in the read-write memory. The starting of the stack is defined by loading a 16-bit address into a stack pointer. Okay, for status of the result, here the flag register is there. There are 5 flags in 8085, that is the sign flag, 0 flag, auxiliary carry, parity flag and carry flag. Okay, and next there is a other block, that is interrupt control. As the name suggests, interrupt, that means it's going to interrupt the current execution of the program. That is, whenever the microprocessor is executing main program, and if suddenly there is a interrupt occur, the microprocessor shifted the control from the main program to the main program to process the incoming request. After request is completed, the control goes back to the main program. There are 5 interrupts in 8085, that is INTR, INTA, RST 7.5, RST 6.5, RST 5.5 and trap. And there is a one more block, that is the serial IO control. Serial IO control block is used for control the serial data communication. It controls the serial data communication by using serial input data and serial output data pins. And all these blocks, that is the serial IO control, interrupt, accumulator, temporary register, flag register, instruction register, time and control unit, general purpose register, all these are connected to the internal data bus of the microprocessor. The data bus, internal data bus of microprocessor, it is a 8-bit data bus. It is a 8-bit, and here there is an address bus and address data buffer. This portion is used for the communication with the outside world. That is, the microprocessor connected using this address bus and data bus. In 8085, 80 to 87, that means the pin number pin 80 to 87 can work as a both address bus and data bus, and pin A8 to A6, A8 to A15 can work only as a data bus. So this is the complete architecture of 8085. In next lecture we will discuss some other topic of 8085. Thank you.